Okay, this one is on similarity in right triangles. So all right triangles, if we have a right triangle, the outside triangle is a right triangle, because we have this 90-degree angle here. If we draw in the altitude, which is from the right angle to the other side perpendicular, so it creates another right angle, then all three of the triangles created are similar to each other. Okay, so they're similar by angle. When I separate the triangles out, it's a little more obvious to see how the angles match. So angle B is a right angle, and I'm going to draw these two triangles down here. So go ahead and pause it if you need to draw these triangles. But I have this big triangle, this is the outside triangle ABC. This medium-sized triangle ABD is this one, and then DBC. And then on DBC and ABD, these are the right angles, the ones that are bordering D. So if I mark angle A with a bend, just so that I can, when I separate the triangles, I can tell which angles are the same, and then angle C with two bends. I haven't marked any angles congruent that aren't congruent. I just made an angle notification in it so I can tell which ones they're the same as. So angle A on this big triangle is also angle A on this medium-sized triangle. And angle C on this big triangle is also the same as angle C on this baby triangle. So these two triangles, this triangle angle matches this triangle's angle, and this triangle's angle matches this triangle's angle. So the triangles are similar by angle, which means this angle B has two angle bends and this one has just one, because that's what was missing from the similar triangles. And in similar triangles, all the angles are the same. So then if I write my similarity statement, I can call the first triangle whatever I want. So I'll call it ABC. It doesn't matter what order you pick for the first one. I went from the one angle bend to the 90-degree angle to the two angle bend. So 1 to the 90 to the 2. So when I'm doing my corresponding order for this one, I want to start with the one angle bend, which is A, then go to the 90-degree angle, which is D, and end at the angle that has two arcs in it. And then again, 1 to the 90 to the 2, so B, D, C. And there's one for you to practice on that side, that set. Okay, so if I separate these out, I'm going to put one angle bend in P and 2 in R, and my 90-degree angle, of course, is S. Okay, so notice there's an angle missing in both of these. We don't have anything labeled for the right angle piece of the medium in this smaller triangle. But this one has a 1 and a 90, so it's missing a 2 angle bend. This one has a 2 and a 90, so it's missing a 1 angle bend. So if I call the first triangle, I'll just start with Q this time. Q, P, R. 90 to the 1 angle bend to the 2 angle bend when I named it. So then I would go from this one, 90 to the 1 to the 2. So S, P, Q. 90 to the 1 to the 2 is S, Q, R. Okay, when we're finding the value of X, we're relying on the concept of proportions. So these triangles are all similar, which means all the corresponding parts are similar. So if we can identify from each triangle the short leg, long leg, and hypotenuse, we can create a proportion chart and then pull whatever proportion we need to. So I'll just do an example on number 4, for instance. So if I have number 4, I have there's 3 triangles. There's a big triangle, a little triangle, and a medium-sized triangle. Okay, the big triangle would be this outside one. The little triangle would be this little skinny one, and then the medium-sized triangle would be the other one we can clearly see. Then in each triangle there's a short leg, a long leg, and a hypotenuse. Okay, so what we want to recognize is on the big triangle, all 3 sides are actually given. So if I ignore this X right here, this triangle has 7 as the short leg and 24 as the long leg, because again the legs border the 90-degree angle, which is here on the big triangle. Okay, so my short leg would be 7, and then my long leg would be 24. And then my hypotenuse, which is the side not touching the 90-degree angle, is 25. On the little triangle, I'm given the longer of the two legs, because this is longer than this, and this is the 90-degree angle, and then the hypotenuse. So the long leg and the hypotenuse are x and 7. And then on this triangle, I'm given the shorter leg of the two legs, so this would be x versus this, and then the hypotenuse. Okay, so the proportion chart is nice because you can cross out any one row in any column, and you'll be left with the proportion. So if I just choose to cross out this row and this column, my proportion is 7 is to x, 7 over x equals 25 over 24. So you want to cross out columns that have blanks in them, otherwise you're going to have blanks in your proportion and you won't be able to write one. Okay, so 25x equals 168. Dividing both sides by 25 gives me 7.2, so 6.72, sorry. So you can try that concept for 2 and 3 as well. If you didn't understand that, you can just pause it, rewind it, play it back. Okay, the geometric mean of positive of two numbers is a over x equals x over b. So basically, whatever number x is going to be repeated in the bottom left, top right, or top right, bottom left. I said the same thing twice. But they're cross products of each other. So when you cross multiply, you get x squared equals ab. So if you square root both sides, x equals the square root of ab. So to find these geometric means, this is their formula. So it's going to be x, which is the geometric mean, equals 6 times 30. Okay, from Algebra 1 last year, we're going to break this down into either prime numbers or perfect squares. And once we get all prime numbers or perfect squares, we can stop breaking it down. But until then, we want to continue to break it down. So 6 breaks down into 2 times 3, and 30 breaks down into 6 times 5. 3 is prime. It's only divisible by itself in 1, so 3 times 1 is the only way to get 3 for multiplying whole numbers. 2 is prime. 6 I can break down. So I'm going to bring down my 3, I'm going to bring down my 2, I'm going to break down my 6. So this is still 3 times 2. And then I have a 5. So couples come out in society as one, just like in marriage. If 2 people get married, they come out in society as one. Flesh, you're supposed to. And then singles stay in the radical, so stay underneath the radical. So these two 3's will get crossed out and come out together as 1 3. So whatever number you were, that's what you come out as. These two 2's would cross out and come together, out together as a 2. Everything that gets brought outside multiplies together, so you have 6 radical 5. There's still 1 5 below and some 5 underneath. Okay, 16 times 28. 16 is a perfect square, so we don't need to break that down. 28 can be broken down into 7 times 4. 7 is prime. There's no numbers that multiply to give us 7 that are whole numbers. And then 4 is a perfect square. So we're done. So square root of 16. So in this time, I don't need 2 of the same number if I have a perfect square. So if I type in the square root of 16, what I mean by perfect square is it comes out to a whole number. So it's just 4, so that would turn into a 4 on the outside. And then 4 is a perfect square of 2. So you pull out 4 times 2 on the outside, so you have 8 when you multiply those together. And then 7 is not a perfect square, so it would stay underneath. Okay, and then there's one for you to try. Alright, and then geometric mean and altitude theorems. These are shortcuts to doing the table. You can do the table every time that we did on the front. It will work, it's just that it's a little time consuming and there's some shortcuts. So on your formula sheet that we created, these labels for the outside triangle, there's always a short leg, a longer leg, and you're just visualizing these, and then the hypotenuse. So whichever one's shorter of the 2 legs, that's the SL, the short leg. The altitude is what's drawn from the right angle on the big triangle to the hypotenuse, but it's at a right angle. And then this stands for hypotenuse piece closest to the long leg, and this stands for hypotenuse piece closest to the short leg. And these are our rules. So if you're looking for this segment, it is equal to the geometric mean between these two pieces, the hypotenuse piece closest to the long leg times the hypotenuse piece closest to the short leg. If you're looking for this, it's equal to the piece closest to it times h, the geometric mean between those. And same thing for SL, the piece closest to it times the whole thing. So we're basing all of that off of the geometric mean rules. So again, this is our longer leg out of the two. This is the short leg. This is the altitude. This is hypotenuse piece closest to the long leg because it's closest to the long leg. And hypotenuse piece closest to the short leg because it's close to the short leg. And this is the whole hypotenuse. So the altitude rule says that altitude is equal to the square root of HLL, so the hypotenuse piece closest to the long leg, times HSL. So we want to set up this equation for all of these problems and solve. So in this picture, the altitude would be x equals the square root of the hypotenuse piece closest to the long leg. This would be my long leg, so this is my HLL, is 12. And the hypotenuse piece closest to the short leg is 8. Then we break it down like we did before. And I have 4, which is a perfect square, 3, which is prime, 4, which is a perfect square, and 2, which is prime. So the square root of 4 is 2, and the square root of 4 is another 2. So I have these two prime numbers get multiplied together, 4 radical 6. Okay, on 10, my altitude is 18 this time, and then my hypotenuse piece closest to the short leg and long leg are x and 15. This one I wouldn't break it down because I don't know x, so I can't really break x down if I don't know what it is. So I'm going to square both sides to solve for x. I need to get x alone. This one already had x alone, so that's why we could just break it down and find the simplified version of the answer, because this is technically the answer. So 324 equals 15x because the radical cancels with the square. So 21.6 is what x equals. On number 11, we want to come up with an expression for this piece because we need altitude, which we have 21 on, equals the square root of HLL, which is 30, times HSL, which we don't know. But if the whole thing is x, then this is x minus 30. We have to subtract out the 30 piece. So we take the whole length, but we subtract, which means to go back, 30. So this is going to be x minus 30. Solving this, we square both sides. Whoops. So 21 squared is 441. And then this is our problem. We're just going to solve it like a regular equation from Algebra 1 last year. Distribute and solve. So when we distribute the 30, we get 30x minus 900 equals 441. Adding 900 to both sides. And then dividing by 30 gives us x. Okay, then we have the geometric mean rule. Geometric mean leg rule. So this one is saying the long leg, short leg, HLL, HSL, altitude, and hypotenuse. The long leg is equal to the HLL times the whole hypotenuse. And the short leg is equal to the HSL times the hypotenuse. So basically what you're making sure you can do is identify these segments in the picture. So you're looking for this long leg to equal the piece closest to the long leg on the hypotenuse and the total hypotenuse. So x equals the square root of HLL, which is 24 is the piece closest out of these two, and then the whole hypotenuse, which is 26. Okay, so we can break this down to 6 times 4, and this to 13 times 2. This is 3 times 2. 4 is perfect square. Okay, so I can take the square root of 4 is 2, so I can put 2 out for the 4. And then I have 2 2's. So 2 2's comes out in society as 1 2. And I'm left with 4 radical 39 if I multiply. Okay. I did in most classes, I did both of these, so I'm going to do 15, or I did 14, so I'm going to do 15. 15, you want to use this rule. So pause it and see if you can set up, with all letters and everything, these rules. There should be 3 different equations because you have things on every single side. Okay, so this is the long leg, short leg, hypotenuse, HLL and HSL, and altitude. So what I want to look for is which of these equations do I have only one unknown. So out of A, HLL, and HSL, A, HLL, and HSL, I only have one unknown. I only don't know X, so I actually can solve that first. So I'm going to do 8, which is the altitude, is equal to the HLL times the HSL, and I can solve that equation. So squaring both sides, you get 64 equals 20x. X equals 3.2. Okay, now that you know this is 3.2, you want to actually substitute it in. Whoops. And you can use the short leg and long leg rule. So I'll set them up, and because of time, the bell's about to ring, I'm going to do just the setup, you can solve it. So for the long leg, that's y equals the square root of the piece closest to it times the whole thing. So again, I'm looking at these formulas from the sheet, and I'm picking out these segments. Short leg, the segment is z equals the square root of 3.2 times the whole thing. And then you can just do these on your calculator.